Okay, this is one of the homework sheets. It was questions 1 through 8, so this is number 1, and you're supposed to find f prime for each of these problems. So if you take the derivative of this, you must take the derivative of this, and now you have the second fundamental theorem of calculus, which states you're just going to take this x and you're going to put it in wherever you see a t, so you get x minus 1, and that's the answer for that one. Okay, this is number 2. Again, we'll take the derivative of both sides, and we're going to take the x and we're going to put it wherever we see a t. That's the answer for number 2. Okay, here's number 3. Take the derivative of both sides, and that means wherever we see a t, we're going to put an x squared. But don't forget, whatever answer we get, we must multiply it by the derivative of this upper limit, which is 2x. And if you wanted to simplify, you could distribute, so we get negative 4x cubed plus 4x, and that's the answer. Okay, here's number 4. Again, take the derivative of each. We're going to put 3x wherever we see a t. So I'm just going to be a little careful here with I'm going to put parentheses wherever I see a t, just because there's exponents involved. Okay, so this is what we'll get when we put 3x in for everything, but don't forget then we're going to have to multiply that by the derivative of 3x, which is 3. Okay, so if we clean this up a little bit, we're going to get a negative. 3 to the third power is going to be 27. Okay, plus 11 times 9x squared. We don't want to make any silly mistakes. Minus 107x plus 44, and this is all still going to be multiplied by 3. I mean, this is just algebra really at this point. But not terribly difficult. Okay, I think we can simplify one more time. So 11 times 9 is 99. Still all multiplied by 3, so we're just going to distribute now. And we're going to get a negative 81x cubed plus 297x squared minus 351x plus 132. And so that's your answer. Okay, take the derivative of both sides. So we're just going to rewrite it. So we have 1 over t cubed. I'm just going to put parentheses instead of the t. And I'm going to put the x cubed in there. And don't forget, I need to multiply whatever that's going to be times the derivative of the x cubed, which is 3x squared. So this will give me 3x squared over. So we have x cubed to the third. So when it's an exponent to an exponent, we multiply that. Sorry, that was my phone. We get x to the 9th. And I'll cancel out 2 here, and I'll cancel out 2 here, and your final answer should be 3 over x to the 7th. Okay, so now we're coming across something a little bit new, because we always said that it needed to be one of these limits here have to be a constant, and one has to be an x. And now we have both of them. So actually, there's a little secret for doing these. And so once we take the derivative of both sides. So we'll be using the second fundamental theorem of calculus, but you can't do that with 2 variables. So we're going to have to break these into 2 of them. So we're going to have d dx of the integral from x to 0, and then we're going to have to do d dx going from 0 to x squared. So we'll do one integral, then the other integral, and then we just add them together. So we're going to go from x to 0 and then 0 to x squared. And then we'll just put them together, okay? The only problem is for this first integral, we can't have 0 on the top and x on the bottom, so we're going to have to flip that around. And in doing so, we have to add a negative. And this one is perfectly fine. 0 is on the bottom. Okay, so now these are all set up, and now we're just going to do what we know how to do. So let's make some room here. Okay, so let's work on the first integral first. So we have a negative, and then this should be a minus over here. Wherever there's a t, we're just going to put this x. So we're going to get negative 2x minus 2. So that's the first one, plus. And now for the second one, wherever there's a t, we're going to put x squared. So we're going to get negative 2x squared minus 2. But don't forget, you have to multiply by the 2x. So if we clean this all up, negative and negative becomes positive. And then we're going to distribute this 2x. So this will give us a negative 4x to the third minus 4x. And I believe we can simplify a little bit more. So we have a 2x and a negative 4x gives us negative 2x minus 4x cubed plus 2. And that's going to be our answer. Okay, here's number 7. Add a derivative to both sides. And we have the same issue as before. It's going from x to x squared. So we're going to make two integrals. One going from x to 0. And then to that, we'll add the integral going from 0 to x squared. Okay, but we cannot have the x on the bottom and 0 on the top, so we're going to have to flip that to go from 0 to x, and we have to add a negative in front. Okay, and in the meantime, we can work on this one. So wherever there's a t, we're going to put an x squared. So that's what we get when we put the x squared in, but we have to multiply that whole thing by 2x. And hopefully you're really getting the hang of these by now, because they're kind of fun, you have to admit, and not very difficult. Okay, so for the first one, we're just going to get this. Right, so this was just the negative from here, and then I put the x in wherever there was a t, here and here, okay? Plus, this gives us x to the fourth, and that's all multiplied by 2x. Okay, we'll just simplify a little bit, do a little distributing. Okay, so I'm going to distribute all this, okay? Okay, and not too much that we can combine, but we do have an 8x and a 22x to give us a 30x. And we're done. And finally, this is the last one, number 8, and we'll take the derivative of both sides, and again, we're going to have to break it up into two integrals. So we're going to go from x to 0. Then we're going to go from 0 to 2x. Okay, and again, we have to flip this so the 0's on the bottom. And we can go ahead. And for the second integral, we're going to just go right ahead and put that 2x in for t, and we're going to have to multiply that by 2. Okay, I think we're ready to put everything all together. Okay, so for the first one, we're just going to put the x in for t, and we're going to get 2 over x plus 4 over 2x, and this can be reduced because 2 goes into 4 twice. And 2 over x plus 2 over x. Oops, messed something up here. This first one, we forgot, there's a negative here because we had to flip it. So it's a negative 2x plus a positive 2 over x. A negative 2 over x plus plus 2 over x, so they cancel each other out, and we get 0. And that was the answer, and we're done. Woohoo!